Okay guys, welcome back to my channel. Thank you for tuning in. All right, so now we want to focus on matrices. So I'm going to go over the November 2016 paper 2. All right, so with these ones I've already solved these problems, so I'll just go ahead and explain. It is given that AB is equal to 1001 and A inverse is 1000. Then we're also given 100, negative 110, negative 1, negative 1, and we are given B inverse. So we want to find A B inverse, and hence or otherwise we need to solve that systems of equations. Okay, so the first part here, right? So on the first part, guys, remember this rule here. You need to know this property that if you want to find A B inverse, it is the same as saying B inverse A inverse. It's not like A inverse B inverse, but you commute, then you take the inverse while you commute the A and B, right? So we are given our B here, our B inverse and our A inverse. So we just go ahead and multiply those matrices row by column, and we get that row by column, row by column. You do the same until you get this part here. Then when you simplify, you're going to get negative 9, negative 32, 14, 2, 7, negative 3, negative 1, negative 2, and 1. Right, but there are certain people, individuals, probably you are in the exam and you forget this row A B inverse, the properties B inverse A inverse. So what you simply do is to first find product. Unfortunately, we cannot do that because we don't even have matrix B. So that's the only way to go here. Otherwise, you're going to stuck. But if we are given matrix B, so I would say first find product A B, then you follow the steps, right? Then we also have here the question is saying hence or otherwise. So hence means use the above result, otherwise you're going to use any other means. So this one was easy because x is equal to 1, right? So when x is equal to 1, you just plug in here. So you just say 1 plus y equal to 2. So again, your y is equal to 1, right? Then here, 3 times 1 is 3, plus 2 times 1 is 2, plus z is equal to 1. So my z will be equal to 1 minus 5, which is negative 4. So my x is 1, my y is 2, 1, and my z is negative 4. But we can do it using the matrix method. So the matrix method here is this one. So you have, you take the coefficient. So this is 1x. So the coefficient of x is 1, but you don't have y, you don't have z, so you put zeros. Here, the coefficient is 1, 1, and z is 0. Here, the coefficient is 3, 2, and 1. So you have this matrix, which you multiply with x, y, and z, right? So you've expressed everything in matrix form. So now, this is exactly what I did here. Then you perform your matrix. Remember, for matrices, when you have A times X, Y, Z, maybe is equal to maybe a certain number. So to get rid of A, you pre-multiply by the inverse here. You pre-multiply by the inverse. Remember, if you multiply a matrix by its inverse, you get the identity. And when you multiply the identity by any matrix, that matrix remains unchanged. Then here you just simplify, you multiply as normal, right? So this is exactly what happens here. My inverse, remember, the inverse was this one. The inverse for A is given here. Where is it? Oh, sorry. The inverse for A is given here is 1, 0, 0, negative 1, this and that, right? Because as you can see, this is your matrix A, 1, 0, 0. That's my matrix A here, right? So you needed to be swift to catch that out, right? So your matrix is here, right? So now I multiply A, I pre-multiply A by its inverse, but I do that on both sides. Then from there, when you multiply matrix and this, you get your identity. And if you multiply an identity by this, it remains unchanged. Then here, when you multiply, it's 1 times 1, then it's just 1. Here it's negative 1 plus 2 plus 0. Here it's negative 1 minus 4 plus 1. When you simplify, you're going to get this. So your x is 1, your y is 1, and your z is negative 4. And that's all we needed to know on this particular question, guys. Right, let's see the next question.